In this video, we shall examine some introductory programming concepts. Open in front of us is the RStudio environment. We have on the top left-hand side our script window, bottom left-hand side our console, top right-hand side our global environment, and the bottom right-hand side our local files environment. Currently, in my local files environment, I have set the working directory to be a folder called rcode, where all the code that shall be written in the script environment when saved shall show up over there. To start off with, we can start by describing what the purpose of this script is. And one can do that by first inserting a comment inside a script. To insert a comment in an R script, one uses the hash sign. When one uses the hash sign, one can write in text that is not compiled or interpreted by the R application. For instance, I can type in Intro to Programming Concepts, and this is considered a comment and will not be executed when I run it. For instance, if I select this line, and all I'm doing while selecting this line is dragging my cursor across that piece of our script, and I'm hitting run, the run button, you can see it's considered a comment, nothing happens. Another way one can execute specifically this line, if we want, on a line-by-line basis, is to use either the Control Enter or the Command Enter buttons on a Windows or a Mac. If one wants to start saving an R script file, one can do that by hitting this floppy disk icon. When one hits that, you get an opportunity to save this, and you can see that it's going to save this script in the rcode folder. I shall call this intro_pc.1, intro to programming concepts.1. If I hit save, you will see that that file shows up in my current working directory called rcode. The first programming concept to be introduced to us is that of variables, and so I shall specify the topic that is going to be covered next, which is variables. Variables are places in the computer's memory or in our application where we want to store data. This data can be manipulated and managed in other parts of the script as required. There are some conventions to variable names. They always need to start with letters. They can include numbers or the dot or the underscore sign. Other special characters are not allowed in variable names. For instance, I can have a variable name such as this. I have a variable name called client name. To this variable, I want to assign a value. In this case, the value I will be assigning, and the way I assign that value is going to be through the use of an arrow operator. The arrow operator is represented like that. The name of the client in this case is Jim Butcher. Please notice that Jim Butcher is considered string data or text data and is subsequently in quotes. One can either use single quotes or double quotes. One of the other things that we are going to be using while naming variables is a standard known as camel casing. Camel casing is when we have multiple words in our variable name. Each word starts off with a capital letter. In this case, name that is affixed to client starts with a capital letter. As you can see, I can have multiple variables, and variables can hold different data types. So for instance, let's assume that our client, Jim Butcher, goes to a restaurant and the bill for his food totals $50. Let's assume the tip that Jim Butcher pays or wishes to pay on his food bill is 20%. And so we're going to call that 0.2. As we can see, with these three variables, each variable holds data of a different type. The first variable holds data of character or string type. The second one holds integer data. And the third variable holds decimal data. Let's say Jim Butcher spends $50 at a diner. The name of the diner is the Pirates Bar. You will notice that there is a small problem over here. I have an X right next to line 9 that has the diner name set up. The reason I have this problem over here is because I want the R letter within the diner name to be surrounded by quotes. Now, if one wants to have quotes within a string, one needs to use different types of quotes. In this case, since the entire string is enclosed in double quotes, my choice is to use single quotes to enclose the R within pirates. If I wish to use double quotes to enclose the R within pirates, I might want to use single quotes to capture the entire string. So if I replace this with single quotes, one notices that the error is gone. Variables can hold other data types as well, including Boolean data types. For instance, did Jim Butcher like the meal at the Pirates Bar? This says I've declared a Boolean variable called liked meal that is set to true, that he liked the meal at the bar. If I want to save the code that I have written so far, I click on, again, the floppy disk icon, or if you are on a Mac, you can hit Command S to save. The asterisk symbol right next to the name of the file indicates that the file currently has not been saved. I'm going to hit Command S, and you see that the asterisk symbol disappears. This file has been saved. Now, if I actually want to execute these lines of code, I have a couple of options. The first thing I can do is I can select all of these lines that have variables declared, and I can click on the Run button right here. So this Run button either runs the current line, the line your cursor is at, or the selection. In this case, I have selected quite a few lines, and if I click on this Run button, notice that this code is actually executed in the console, and once it is executed in the console, these variables also show up in the R global environment. And so the R global environment allows us to keep track of the code that has been executed and the status of our variables. One can also look at the history and see that these are the lines that have been executed so far. Now, if one wants to clean up their R global environment, one can just use this broomstick icon to clear objects from the workspace. And it's going to remove all the objects from the environment. And if I say yes, my global environment is empty. It does not change the code that I've written, but I can no longer refer to variables in the global environment assuming that they exist. So if I want to, at line 13 now, do something with client name, assuming it already exists, well, it doesn't exist, I'm going to have to run lines 5 to 10 once again to make sure these variables are actually in the global environment for me to then manipulate them. And so what kinds of manipulations can one perform on variables? There are lots of different operations that one can perform on variables. Some of these operations are arithmetic operations, such as addition, subtraction, multiplication, so on and so forth. So the usual arithmetic operators. And so, for instance, let's take a look at an example of and typical arithmetic operations: the plus, the minus sign, the addition, subtraction, division, multiplication, parentheticals are the types of operations that can be performed. For instance, if one wants to find out the total bill that Jim Butcher has to pay, including his food and the tip, I can have a variable, a third variable called total bill. Now, this total bill is going to store the value or some calculations. And so the value in total bill is going to be the food bill, the value of food bill, or the value that is stored in food bill, added with, I'm adding food bill times the tip percentage. So the total bill is the food bill in addition to the tip on that food bill that Jim Butcher wishes to pay. Now, if I select this line, or if I leave my cursor over here and just hit Command Enter, this line is going to execute. But I'm going to find an error show up. This error is telling me this object, food bill, is not found. And that is because food bill, I had cleared the global environment, so food bill as a variable doesn't exist. And so one of the things I can do is I can execute lines 5 to 10 once again, so that line 18 successfully executes because food bill and tip percentage would then be present in the global environment. I'm just going to, instead of selecting those 5 lines and clicking on the run button, I'm going to be using Command Enter to move from executing the first line, second line, the cursor automatically moving down line by line by line. As you can see, I pressed Command Enter on the first line and I have client name show up. Food bill now shows up. Tip percentage shows up. Diner name shows up. And whether I've liked the meal shows up. The next couple of lines of comments, nothing's going to happen. And when I execute the next line, total bill, I see that the total bill is now $60. That's 50 plus $10 as a tip. The total bill is $60. And we can now see that the arithmetic operations performed for the calculation of the total bill is an addition and a multiplication taking place. Now, while I have said total bill equals to, the equals to operation, the equals to is considered an assignment operator. And so instead of using an equals to operation, one can also use the arrow operation for assignment. I can also use an arrow operation instead of the equals to operator for assigning total bill of value. Another type of operation that is possible in R are relational operations. Relational operations allow us to compare values. The typical relational operations we might consider are greater than equal to, less than equal to, and not equal to. An equal to, or a comparison of two values, is signified by using two equals to signs instead of a one equal to sign. The one equal to sign is considered an assignment. Two equals to sign are considered comparisons. So let's take a look at this. For instance, if I were to compare the total bill, let's say Jim Butcher can only be reimbursed if his bills are less than $100. And so reimbursed is a variable that's going to store the result of the comparison of total bill to $100. If total bill is less than $100, reimbursed is going to be true. If total bill is greater than $100, it is going to be false. And so when in fact, I might want to make it less than equal to, because I can imagine Jim Butcher spending around $100 and not being reimbursed because he is at $100. So as long as it's less than or equal to $100, Jim Butcher is going to be reimbursed. And let's see whether he is in fact reimbursed or not. I'm going to run this line. And once I run it, I see the value of reimbursed in the global environment is true. Now, this value is not actually printed out, but if I do want to print it out, I might just type in reimbursed and execute that line by itself, and you will see that reimbursed is printed out to be true. And so we know that Jim Butcher is in fact going to be reimbursed for this meal. And so I can use relational operators to compare values, and I can perform a variety of such comparisons. In addition to relational operations, R allows us to perform logical operations. The two logical operators are the ampersand signs, that represents the AND logical operation, and the two pipe symbols. Pipe is a symbol that's present above the enter key on your keyboard. To get the pipe to display, you want to hold down the shift button and press the key right above the enter key. And two pipes represents the OR operation. Let's say that Jim Butcher, who went to the Pirates Bar, is asked by his co-workers if he would recommend this bar to his colleagues. And there is a condition that we want to check for his recommendation. And so I have a variable called will recommend that stores whether Jim Butcher will recommend this bar. The conditions for recommending this bar is that Jim Butcher liked the meal and that the company will reimburse for expenses at this bar. And so will recommend will store the result of the bill amount, the total bill being less than $100 or less than equal to $100, but also whether he liked the meal or not. And so, will recommend is going to store whether the combination of whether the total bill was less than $100 and Jim Butcher liked the meal. If either of those conditions evaluate to false, then will recommend will hold false. If both those conditions evaluate to true, will recommend will be true. And so the two ampersand signs over here are an AND operation, looking for both of these expressions to be true. And if I run this line, I see that will recommend holds the value. And if I print it out, I see that the value of will recommend is true, indicating that both the total bill was under $100 and he liked the meal. And so he would, in fact, recommend this bar to his colleagues. Well, Jim Butcher might have liked. In addition to logical operations, one can also sometimes find, in most programming languages, certain miscellaneous operators. Specifically in R, one of the miscellaneous operators is the colon. The colon operator allows us to create a range of values. For instance, Jim Butcher has been asked to assign a rating to this diner, the Pirate's Bar. And so we need to create a ratings meter. The way one can create a ratings meter is provide a value of 1 to 5 to Jim Butcher, from which he then picks a certain value. And so I'm going to use this range operator to create these ratings. And so to rating meter, I have assigned the range 1 to 5, and if I execute it and display the rating meter, one sees that it holds values 1 to 5. Most programming languages have built-in functions that can be employed. R, like most programming languages, has a built-in function that we can use. Some functions are functions like print. The print function allows us to print out the values of variables. In this case, let's say I want to print out the diner's name. And if I execute this line, I see that the variable name is now printed out. In this case, Pirate's Bar. One can have multiple such print functions, one after the other. Another function that we can use is a function called cat. The cat function allows me to display multiple variables or strings of text, for instance, like this. As you can see, cat allows me to concatenate strings together. The name of the client is client name, and he ate at diner name. The name of the client is Jim Butcher, and he ate at the Pirate's Bar. All the cat function is doing is it's taking the multiple strings that may be strings or variables and printing them out as a string with each variable appended to the string before. Another function that we can use is a function called class. The function called class tells us about the data type of specific variables, such as the data type of diner name is character data type. The data type of food bill is numeric. The class of like meal is logical, or data type of like meal is logical. The class of tip percentage, or data type of tip percentage, is numeric, and so on and so forth. Another function that we might find useful is a function called rm. The purpose of rm is to remove variables from your working memory or your global environment. For instance, if I want to remove the recommendation, I can type in rm will recommend, and if I run that line, one notices that will recommend, that was a variable listed right here, is now no longer present in working memory. One can also remove all the variables in working memory without necessarily using this broomstick. For instance, there is a function known as ls. ls is a function that lists out all the variables in the global working environment. And so I've listed all the variables. They are client name, diner name, food bill, light meal, rating meter, reimbursed tip percentage, and total bill. If I want to clear out all of these variables that are listed out in the global environment, I can type in rm ls open close parentheses. Or the list of variables I want to remove is depicted, or is going to be provided by the ls function. And if I run this line will remove all the variables listed by ls, thereby clearing the global environment completely. This has been an introduction to a few programming concepts in R, specifically variables, the operations that can be performed on variables, and some functions that are accessible with